Welcome everyone to our tutorial about data science for real estate. The goals of this tutorial is to introduce real estate to data scientists, essentially. Real estate is a fascinating industry. There are very many interesting data science problems that are currently not really being addressed by data scientists in real estate, because there are not that many data scientists who work in real estate actually, and we want to change it, and that's why we were giving that tutorial. The presenters today is I'm Bekkerman, the CTO of Cherre. Cherre is a real estate data aggregation platform. With me is Foster Provo, who doesn't really need to be introduced. Is a full professor at New York University. Is really well known and very active in the data mining community. Gave many invited talks and have many best papers awards. And he sold his startup to a big brokerage called Compass, and now he is a distinguished scientist in Compass. And we have two more people from Airbnb, Ali Rao, who is the senior data science manager at Airbnb. She is an econometrist by training, and she's managing a big real estate data science team at Airbnb, and we'll hear her later on. And Vanya Yosifovsky, who is the CTO of Homes at Airbnb, and before that he was the CTO of Pinterest, and before that he built a very successful industrial research career. The outline of our tutorial today is we're kind of splitting the first portion to three parts. I'll start with introduction to real estate, and then I'll focus into commercial real estate, something that I'm quite familiar with. Then we'll let Foster talk about residential real estate, and Ali talk about short-term residential, which is what Airbnb is focused on. Then we'll have a short break, or probably not that short. And in the second part of the tutorial, we will have a fireside chat. So the four of us will be just discussing the new frontiers of data science in real estate. So we'll spend like about an hour together when I'm going to be presenting. So like we have to kind of introduce myself. Usually when someone is giving a KDD tutorial, they just dive into the technical material, and no one really knows who the presenter is. I don't want to be that presenter. So a little bit about myself. I'm definitely not a novice at KDD. Presented my first paper in first KDD paper in 2009, and gave my first KDD tutorial in 2011. I worked as a data scientist at LinkedIn back then. And we were about to publish the book about scaling up machine learning, so that was my tutorial. In 2013, Foster organized a panel about how to make money from data science, and back then I was the chief data officer of a big venture capital fund, so I was a panelist on that panel. Co-hosted KDD Cup for a couple of years, was the KDD social networking co-chair for 3 years. Here's Faisal and me are doing some stand-up at the opening ceremony of KDD. That was pretty embarrassing, I would say, but fun. I have a best reviewer award, and overall, over many years, I've read and reviewed really many KDD papers, and I can say that I have never seen pretty much any KDD material that is related to real estate, and this is something that we really want to change. So I'll start saying that real estate is really big. So like arguably this is the biggest asset class in all the financial sector. No one really knows what the size of the real estate in the US is, even not talking about the world. But the number that people are kind of agreeing on that it's something in order of magnitude of $100 trillion. So it is a really big industry. And the industry is also really old. After all, people needed a roof above their heads for hundreds of thousands of years. And the real estate industry as it was shaped like about 2,000 years ago didn't really change that dramatically, which is kind of really unusual and strange to think about. But what is happening over the last half a year is totally shaking this industry. So, people are talking about the death of office space. People start moving out of cities, like before they were moving into the cities because they wanted to live next to their work and to commute less, and now it's the opposite. So the industry is changing really dramatically, and it creates an enormous opportunity. When the industry is so large and the change is so sudden, we definitely can see many interesting trends that are being created and many other trends that are being broken. And that's why it's really important to work in this industry right now. So what is the real estate industry after all? So I'll split this industry, the slide of the industry map to quadrants. First, we have residential real estate and commercial real estate. So residential and commercial, the difference is that in residential real estate, the owner is the individual, and in commercial real estate, the owner is the commercial organization. Sometimes a very large organization, sometimes a pretty small one. And horizontally, we split the domain to owner-occupied, long-term rentals, and short-term rentals. Let's focus in every quadrant and see what we have here. So residential and owner-occupied is just a single-family home in many cases. It's a house that is being owned by the person who lives in this house. It's a very, very big industry, obviously, because there are many single-family homes in America and other countries as well. On the commercial side, owner-occupied is usually a big organization that needs to have an office space that, where the organization resides, where the headquarters is. And say like McDonald's owns pretty much all the real estate of their branches. This real estate is not for investment. They're not trying to make money out of it. On the other side, since they're holding this real estate and this real estate can go up in the price later on, so it's usually profitable to have this real estate. But what's even more interesting for me, at least, is the investment market, when people have real estate in order to make income out of it. So in residential long-term rental, it means that it's a person who owns a house and lives in the house and owns another house and rents this house out. So it's a very small operation, individually owned. Usually you don't have to have a big organization behind it. And if person happens to buy more and more real estate, it becomes already a commercial organization and it's becoming more complex. On the commercial side of the long-term rental, there are many subsectors, and the most important is multifamily. Here's a little bit of a confusion. Multifamily is a place where people live, right? Many families live in the same building. So why is it commercial and not residential? Because it's usually owned by a commercial organization, and it's quite an operation to maintain this property That's why it's still considered commercial, despite the fact that people live there. And the other three sectors are not small either, but probably less of a confusion: office space, retail space, and industrial space. Industrial space is very interesting nowadays. I'll talk about that very little because I don't have much to say, but like, you know, if someone wants to focus on real estate, commercial real estate, the industrial space is very interesting. Now, the short-term rentals in the left side, in the residential market, we have this rental market space that Airbnb created. Before there was no quadrant like that at all. And so Airbnb kind of owns this side of the market. And in the commercial space, it's usually hotels. And fairly recently, we started talking about co-working spaces. We're not going to be touching that much on that quadrant for this specific tutorial. And there are two big chunks of the market that is like cross sectors. One is brokerages. Brokerages are organizations that help you to sell, to buy, to rent, and they are totally cross market. And another section is technology. That's where we are, and it's also cross-market. Technology is helping pretty much everything, but so far it's not really widely spread. So PropTech is not a very big high-tech industry. I'll be talking about mostly commercial real estate. After this introduction, I'll focus mostly on the commercial side. Then Foster will be talking about residential, and Ali will focus on the rental market space of Airbnb. So just probably one, side note, the market is obviously measured by the number of property and the size and the price of the property. So the long tail here is residential. Properties are not really expensive, but there are very, very many of them. There are about 150 million properties in the States, and I'm talking about United States only. But the head of this distribution is the commercial market, where the prices are really large. We can talk about like, you know, a billion-dollar property. But obviously there are not that many properties like that. The saying is that it's about something like 15% of the properties, but the size of the market in terms of the price is about 1/3. So 1/3 is a commercial real estate and 2/3 is residential. It's a very interesting slice here, which is the mid-market between commercial and residential. Those are properties that some of them are commercial, some of them are residential. This is a very interesting slice that is not really being researched properly. And again, someone wants to focus on real estate, that might be a very interesting sub-market to work on. So from now, I'll focus on commercial real estate, meaning that those are organizations that invest in real estate in order to get some income from leases. You can assume that, like, you know, imagine that you are a data scientist working for a big investor like that, and there are really many interesting data science problems that need to be tackled. So I'll start saying that the real estate investment market is kind of not really up to date. Let's put it like that. First of all, it's very local, meaning that real estate investors like buy properties in the very short vicinity from each other. Some of them invest in just one single street in a big city, like, you know, own 10 buildings in a very like landmark important buildings in the city, and you can have a portfolio that is like, you know, $1 billion portfolio. Why is it local? It's because the investors know this area. They've been, you know, analyzing it and working with it for decades. So they know really well what they're doing. And that's also the reason why this market is not liquid enough. So the moment an investor buys, acquires a property, they just usually hold on that property. Even if the property is not doing really well financially, it's very hard for to get rid of it because of they already know what's going on. If they want to go to a different, like, you know, part of the city, I'm not even talking about a different city, it's a completely uncharted territory for them. They just don't know what's going on. So the lack of knowledge is actually like the driving force of the real estate industry, which is kind of really counterintuitive, right? You need, in order to invest, you actually need to know a lot of information. You need to know what's going on with sales prices and leases and management costs and taxes and other features and transportation. Like all this you need to know in order to decide whether you want to invest, like, you know, $100 million in buying this specific property. And all this data needs to be all together in one place, which is not what's going on right now. So let me kind of dig into some of those features that are important for an investment decision. Here's a picture of the building where Cherre's offices are. And first we can like look at the neighborhood features, say transportation. It's really good from the transportation point of view, but it's not a very nice part of the city. So the crime rate is fairly high. In terms of lunches, yes, like, you know, restaurants are all around, no problem. So like this is an interesting investment opportunity if you wanted to ever to buy this building. So the neighborhood features are known. You don't need to dig really deeply to get this information. On the other hand, once we're talking about the building features itself, I mean structural features, that's less obvious. So some of them are obvious, right? So this building has two facades, which is, say, it's increasing the management cost and insurance cost. So like it has its disadvantages, but on the other hand, the building is much more visible because it's a corner building. The number of elevators is important. Like 2 elevators means that it's going to be congestion when people want to come to the office in the morning. 4 elevators, meaning that it's good. And this building, as you can see, is mixed use. So you have a retail on the bottom, services right above it, office spaces in the middle, and some executive suites on the top. So once you decide to invest in this building, you need to know that there's actually like, you know, 4 buildings mixed together here in one building, and you need to take those sectors separately and see how well they're doing. And this is the most important part. Like when you need to invest, when you think about investing in real estate, you need to know how is this building doing? Like, is it actually profitable? Is it, and the questions are related to the lease contract. So how many occupants or tenants you have in this building? Maybe the building is half empty. What are the lease like duration and rate, and all this is very important to know. Unfortunately, if you don't decide to invest in this building, this information is really not publicly available. So it's very hard to get this information. If you decided to invest in it, the owner will provide all this information for you so you can make a smart decision. But you first need to kind of, you know, get really interested in this building. And now, which is even more complex, obviously the price of and like, you know, your decision about investing in real estate depends on what's going on around this building. So on the left is the same building, and on in the middle and the right is those buildings that are adjacent to the one that we're considering. And like something is going on there, right? Like the narrow stripe in the middle is actually a hotel. Do you know how well this hotel is doing? No idea. Do you care if you want to acquire this office building next door? Yes, you actually do. Who would provide this information for you, how well this hotel is doing? No one. So out of the sudden, like, you know, you need to make a very difficult decision. Invest like $100 million in an office building. You don't have a full visibility to what's going on. So you kind of have a chicken and egg problem. Like, you really need to be interested in investing in a specific property in order to get all this information about the property and probably information about what's going on around it. But how can you be interested if you don't know? This is the biggest trouble. The market is actually kind of managing to solve this problem partially. What they're saying is that, yes, you don't have a full visibility yet, but we can talk about one factor that is called a cap rate that is actually giving you in like a feeling, a notion of whether this investment might be kind of worthy or not. So a cap rate is a very simple formula. You take the yearly income minus the yearly costs, and you divide by the size as the price of the property. That is like an invert of how many years it will take you to get your money back. You invested like $100 million, you want to eventually get it back, right? And you probably want to get some more money after that. So like, this is the number of years. So like, if the cap rate is something like 3%, that essentially means that it would take you 33 years to get your money back. And if the cap rate is 10%, then you'll get your money back within 10 years. And that's more or less the range of the cap rate. Cap rate is like, it's, people who know cap rates are very rich, because it's not really easy to figure out the actual cap rate. And real estate investors are talking, like, you know, of cap rates in terms of like, I've seen a building that is an 8. That essentially means like it has a cap rate of 8%, which means that it's like a really, really worthy investment, but it's also a risky one, because the higher the cap rate is, obviously the higher the risk is. Like, you know, no one would pay very high rent in a building that is fairly cheap unless there is a reason for that. So overall, the commercial real estate is all about cap rates, and it's very important to know the cap rates, and not many people actually know the cap rates. We, as data scientists, can actually estimate cap rates. So the formula is very easy, right? So like, you need to take leases and costs, which is taxes and management costs, and the sales price, you have the cap rate. That's so easy. The good news is taxes and sales prices are publicly available in the States, not in every country, but in the US they are. And there are companies that can provide you with lease information and maintenance cost information. So it is technically possible to compute or estimate the cap rate. Obviously, you will have a lot of missing data, but we are data scientists. We can deal with missing data. The bad news is that even if you have all this data, to join it together would be very difficult, because lease data comes per unit, maintenance cost data comes per building, and taxes and sales data is coming per lot. And now we need to make sure we understand what those terms mean. So a lot or parcel, it depends on a specific market, is this real estate, this property that you can buy, you can sell, and it's being taxed. So in residential real estate, it's usually a piece of land on which you have the building. So the piece of land and the building together is a lot. So a building can be split to units. Obviously, in some cases, it's still one lot despite the fact that it's split to units. So you need to buy this lot and rent all the units separately. In some cases, you might have multiple buildings on a lot. In some cases, one building can be split to multiple lots. So each unit is a lot. So this is creating a lot of confusion. Even if you have access to the data, like, joining it together and figuring out what the cap rate is very difficult because of that. But we're kind of lucky. All of them, lots and buildings and units, have addresses. So probably instead of joining on lots and buildings and units, we can join on address. Yeah, it would have been easy, but it's not, unfortunately. So addresses are not normalized in the data, real estate data. So all these are the same address of the same building, and we need to build a normalization system to figure out that all this is just one single building. So let's say that we even can build a normalization system. It's still not trivial because you have a notion of alternative addresses. So say 401 7th Avenue and 403 7th Avenue. Are those two separate buildings or the same? Yes, it's the same building, because in the US, the house number has a range. And if if two numbers are within this range, it's the same building. Some street names have aliases. So 7th Avenue and Fashion Avenue is actually the same. And here are two more addresses, and you're looking at that and you're like, well, those are definitely unrelated addresses, right? No, unfortunately, they are related. If a building is a corner building, in many cases it has an address of an avenue and an address of a street. So all these are addresses of the same property, and like visually it's not recognizable. You need to build an address standardization system to actually figure these things out, and that's what the data scientists and real estate focus, at least in some cases. Okay, let's say that we managed to join the input data and estimate cap rates. Now we know that, this is the area where the cap rates are high enough, which means that we are interested in this specific area, we want to invest. And now, whom should we talk to? So it looks like that's a simple question, right? Like, we should talk to whoever is selling. Well, in commercial real estate, it's not really the case, because if someone is selling, say, an office building, and the building is on the market for quite a while, that essentially means that something is wrong with that building. In many cases, a commercial real estate investor would just acquire the building and hold on it. That, it's a rare case when someone wants to sell it, something bad is happening. So if you really want to buy a good building that nothing is really happening with, you need to create the deal flow. Like, you need to find out who the owner is and contact the owner with a particular offer. So the question is, whom should you contact? Turns out that is not easy in real estate either. So buildings are owned by tiny companies, tiny LLCs that are absolutely obscure. So say the Chrysler building is owned by 405 Lexington, and no one really knows what this company is. There is a large and well-known company behind this LLC, but on the papers, the owner is this small LLC. No one knows what this LLC is all about, and we need to figure out who is actually behind those tiny masking entities, companies that are being used to mask the real owner from the market. So this is not a difficult and not an easy task at all. And to solve it, we need to build a knowledge graph. And actually at Cherre, we have built a knowledge graph that contains properties and addresses and people and companies and other organizations all connected together based on the actions that they have been making. Currently, we have about 500 million nodes and about 1.5 billion edges in the graph, and it covers the entire US market. So all the properties that are in the United States, commercial or residential, are in this graph. So it's very important to build a comprehensive knowledge graph that covers all the markets, because all of them are very connected to each other. So like you cannot build a knowledge graph for commercial real estate and not take into account the residential part at all. This is not going to work. So obviously, I guess you guys are familiar with knowledge graphs. The knowledge graph has the topical locality feature, which means that things that are related to each other will be close to each other in the graph. And they're organized in like what we call semantic neighborhoods. Like we need to separate, like, you know, geographic neighborhoods and real estate, semantic neighborhoods in the graph, which means that those are nodes that are close to each other and they're connected to each other. And if we traverse the knowledge graph, we actually can reveal hidden relationships, and that's where we're heading. Here's an example, a small portion of that knowledge graph. On the far left, we have a real well-known real estate investor called Donald Trump. And Donald Trump is connected to people and companies and properties. Those companies are connected to addresses and other companies and other people. And the relationship between Donald Trump and the person called Paul Davis can be revealed using the traversal of the knowledge graph. And this is not a trivial relationship. If you say Google that, those two names, Donald Trump and Paul Davis, you will just find a different Paul Davis, not the one that we're talking about here. So this how we can use the knowledge graph, and throughout this part of the tutorial, I'll talk about the knowledge graph quite a lot. So we use the knowledge graph to do owner unmasking. Start with a property and traverse the graph until you reach some type of a real well-known real estate investor, which is also a node in the graph, and that is most probably the owner behind this specific property. Two comments about knowledge graphs. Usually knowledge graphs are open-ended, meaning that, like, you know, if we didn't find a relationship into nodes, maybe it exists, but we haven't found it. In real estate, the knowledge graph is actually a closed world, meaning that if, say, Silverstein Properties is not connected to Trump Tower, that essentially means that they just don't have anything to do together. So this is a very interesting and important feature to use. We can assume that the knowledge graph is kind of modeling the real estate ecosystem as is, and if there are no connections between two nodes, that essentially would mean there is nothing that is in common between them. Many real-world graphs are scale-free, and that makes a data scientist's life difficult, because there are those bridge nodes that connect completely unrelated parts of the graph. And the good news is that the real estate knowledge graph is not scale-free, because if you think about it, there is some type of a geographic grounding to the knowledge graph that is being built, because those are properties, and people who invest in those properties, they have these local characteristics of the geography that they are working in, and that's why the graph is not scale-free, which is a good news. Like when we're talking about semantic neighborhoods which don't have bridge nodes, we actually can really well model what's going on in the specific locality. The trouble is to build a knowledge graph, obviously, and because, like, you know, you need to create nodes per entities, and the names of those entities are not normalized. Here on the left side, you have the same person. On the right side, you have the same address, but the graph is completely disconnected. In the real world, it's even worse because it is actually connected, but connected kind of very sparsely. When you look at that graph, you're like, huh, that's a good graph. Since the graph is so large, it's very hard to figure out that the graph is actually pretty garbage. And a lot of work needs to be done to connect all these nodes on the left together and all these nodes on the right together as well. There are very many ways to write the same name of the same person. Here's Aaron Ziegelman, quite a real estate hero. He used to own a lot of real estate in the 80s in New York. And there are very many ways to make a typo in this guy's name. 25,000, what is this number? That's the number of ways to write the name of JP Morgan Chase Bank. So we found 25,000 different ways to write the name of that bank. That would include all the subsidiaries, all the branches, all the typos, everything. Wherever you can make a mistake, someone will definitely make a mistake. As you can see, it's like cleaning the data is a very important part of this, the work in every data scientist essentially, but in commercial real estate especially. I'll give you a few examples. I'll try to be quick here. Say those two names, we taught the system already that it's the name of JP Morgan Chase Bank, despite the fact that they have absolutely nothing in common. We know that it's the same organization. But what about this name? That looks like a person whose first name is Chase, last name is Morgan, and the middle initial is N. Probably that's not a bank, right? But what if you're looking at something like that? NA is actually a very good indicator that it's a bank. And so on the right side, it looks like it's more like a bank. And then you're looking at the left side, you're like, huh, that looks like a bank too. That's probably not a person. Here's another problem. Like Tishman Speyer is a really well-known real estate investor, and the name is very unique. So whatever indicator words like LLC or Corp you add to the end of Tishman Speyer, it's still going to be the same Tishman Speyer. But what if you take a very generic name of a typical a company that owns just one property, say 13 Main Street? If it's LLC or Corp, is it the same company or not? Probably not. What if the indicator word here is company, or say co, right? Co can be Corp or company, so it's becoming really ambiguous. So you have no idea what it's referring to. Here's another example. Meryl Streep, you write it in any order of words, it's still going to be the same person, right? What about David King? If you write David King's name as in a different order, you end up with King David, and that looks more like a hotel or more maybe a restaurant. It's already not a person, just because the order of words is different. Here I just came up with some type of a very rare last name, and the first name is John. So on the right, on the left, it's probably the same person, right? Despite the fact that on the right it's written with a typo. But what about if the name is Joan? That's a female name, right? So it's just one character of a distance. The string distance is 1, but those are probably different people. And what if it's Joanne? You know, like maybe since both of those are female last name, first names, maybe this is the same person actually. And the last example is the decision about how to normalize the data can be very cultural. So I happen to be a Hebrew speaker, and I know that the name on the bottom left is an organization, and the name of the bottom right is a person. But I just happen to be a Hebrew speaker. I don't speak Chinese, I don't speak Spanish, and like I'm pretty sure that problems like that can be in other languages as well. So it's a very difficult task to normalize this data, to build a knowledge graph, but once the knowledge graph is built, we can apply owner unmasking, and we can find out who the owners of properties are. So let's say that we are commercial real estate investors. We decided that we want to invest in a specific property, and we know whom to talk to because we used owner unmasking. Now, what about the price? It's kind of an existential question, right? Like, what is the price at all? So in some cases, especially in residential real estate, it's not really hard. If those two buildings were sold for 200K, what's the price of the building in the middle, right? I think it's a fairly simple answer, right? But what if you have a big city and it's very diverse, obviously. There is a building that costs 200 million or a building that costs 20 million. And what is the price for Chrysler building if you have this information? It's very hard to figure out, probably, like I would say, completely impossible. So the price is a big, big trouble. And there are really many valuation models that kind of try to estimate the price of a specific property. The simple one is obviously based on cap rates. So if we happen to know the cap rate, if we know that the cap rate is, say, 6%, you can take the data of the property, meaning the lease data and the management cost data and the tax data, and you can compute the sales price just based on the formula of the cap rate. That's very simple, right? The problem is that no one knows cap rates. So like it's very hard to use this formula just because the left side of it is in most cases unknown. So you have many other types of valuation models to apply in this situation. And the most common is comps. Comps is comparable properties. Those are properties that are similar to the one that we're considering and also probably recently sold. So like you know the sales price of the comp. If you know the comps, actually you can very easily estimate the price of the property that you care about. You basically take, so in real estate, you usually talk about the interval price intervals, like, you know, from the cheapest to the most expensive. You just plot those prices of comps, and somewhere in the middle, most probably is going to be the price of building. But like, you know, as you can understand, this is a very simplistic model that in many cases doesn't work. We can come up with a little bit more complex valuation models based on comps, which would be, if you know what the comps are, comparable properties are, you can compute cap rates based on the comps data. So you know the price of the building because the building was sold recently. You know the financial features of that building, so you can compute cap rate, and you can use the cap rate for estimating the price of your building because you know the cap rate and you know the financial features of the building that you care about. So this is working. The only problem is that what is the comp? How can you figure out that the property is a comparable? We use the knowledge graph for that. Usually, the real estate industry is so much not data-driven. Like, you know, a person who deals with real estate would say, here's a comp, right? Like, here, look at that, that's a comp. That's pretty much how the comp is being defined. Obviously, very kind of, you know, hand-wavy and rudimentary. And the right approach is, at least the approach that we're using is to use the knowledge graph. So if you have properties that have similar features and they also are within the same semantic neighborhood in the knowledge graph, or they're in similar semantic neighborhoods in the knowledge graph, then you can infer that those are comps. Once you want to find the comp, you will need to traverse the knowledge graph, right? And with a little bit of supervision, you can say that, like, you know, once you're traversing the graph from X to Y, and you know that X and Y are comparisons because you have some label data, what you can see is that this process explodes really fast because the graph is well connected, right? Like if you go like on the third hop from X, you already end up with millions of properties. But with a little bit of supervision, you can see that the most important paths between X and Z all go through one node, between X and Y goes through one node, which is X, and you can learn the attention vector for the problem of finding counts. So like the attention mechanism here can be used, and it creates a very interesting model, by the way. I'll be happy to talk about that offline. There are other ways of estimating price of a building. This one, discounted cash flow, DCF, is quite involved from the financial point of view, and whoever has taken a financial math class would probably learn this model. So the model is based on the fact of how much money you want to spend now to get some cash flow in the future. And so you estimate how much money property would make, and you kind of discount that amount by how much money you want to invest now to get this cash flow. And then, since obviously you have to have a close horizon here, because otherwise this number would be infinite, you would say that in 10 years you're going to sell this property and you're going to make some profits out of this sale as well. And you need to take this profit into account into the model. Like, again, how much money would you spend now to get that much of a yearly income plus this profit from sales? So this is a more complex model, but it's also more precise if you knew how to estimate your income in the future. And also the problem with this model is that it doesn't take any features of the building into account. That's why there is a completely different model that is called the replacement cost model, which takes only the building features into account. So you say, how much money would it take me now to build exactly the same building that I want to buy? It's all based on construction cost data. So like there are huge tables of like, if you have this type of air conditioning, it's going to cost you that amount. If you have a different type, it's going to cost you that amount. So you sum all these expenses together, you will end up with some amount. And this is going to be the lower bound on the price of the building, because obviously based on that, you are getting an empty building that doesn't have tenants, which essentially means that it's not making any income. That essentially means that you need to work hard to actually bring the tenants to that building, and that costs money. So you end up with a number, but that's usually used as the lower bound of all the prices. And you're combining all those valuations together into what's called the football field. Like the price of the building would probably go from the replacement cost amount that you calculated on the left to the asking price, which is usually above everything else. And you need to come up with a number somewhere in the middle, maybe probably in this case closer to the DCF model performance, but like, you know, it really depends on how you look at that. So anyhow, in real estate, people usually look at the price intervals. There are many automated valuation models that are built by data scientists. Unfortunately, those are simple models. Like you just build a feature vector for a property and you're just throwing it to a regressor. And that's pretty much what those AVMs are all about. Nothing, I've never seen anything like substantially more complex than that. And this is a big opportunity, obviously. Like we can use all the machinery that has been created in the data science domain for over the last like 10 years to actually build a better model. And since those models are so simple, actually they don't work well in practice. So the result of that, the prediction of the price in commercial real estate, is pretty bad, because like you remember, like, you know, if you want to estimate the price of the Chrysler building, it's very hard to build a model, a machine learning model for that. So we have an internal joke at Cherre that is saying that there are only two factors actually that affect the price of a property, which is the buyer and the seller. And if you don't take those two factors into account, it's very hard to assess the value of the property, because the seller will sell the same building for different prices to different buyers. It's a negotiation process, right? So probably a better approach for estimating the price of the building is first to use owner unmasking to figure out who the owner is, and we need to use link prediction in a knowledge graph to figure out who might be a potential buyer. Again, don't forget that we're talking about commercial real estate, in which there are not that many big players. Like, you know, if it's a big organization that currently owns the building, it will probably sell that building to another big organization, well known. So like what we need to do is to predict who the buyer might be. And once we have this prediction edge between the seller and the buyer, we can build in a very, very specific AVM model, a valuation model for this specific pair. And this is probably the future of AVMs. Now, the biggest question is like that, like, okay, we can predict this is going to be the buyer, but why the seller will want to sell it all? And this is a very big question. So there are a few real estate types of real estate players. One is a developer who is building, basically constructing the building and then selling it. Another one is a flipper who buys the property, kind of, you know, does a little bit of repairs here and there and sells it. But the vast majority of real estate investors, they just buy property and hold on it because this property is producing income. Why should they sell it, right? And they sell a property only in the case of a distress. Distress is a very important question, especially given the fact that we're talking about our times when, you know, when COVID struck really badly, and there are many aspects of this distress that we need to take into account. One is obviously the structural, so like, you know, the roof is bad in this building. This is a simpler type of distress. If the owner is strong, the owner will invest money, fix the roof, right? There is a second type, which is occupancy distress. The building is okay, but the tenant just left. The building is empty or half empty. How do you deal with that? So this is not that impossible either, because, you know, you use your marketing skills, you make this building full again. But there is this third type of distress, which is more difficult to deal with, and that's the tenant distress. The building is okay, the tenant lives in this building, but the tenant doesn't have money to pay for some reason, and this is a very common case nowadays with COVID-19. So the tenant doesn't want to leave, and the owner doesn't want the tenant to leave, but there is no cash transaction here. So like how to fix that problem, it's very difficult. And the fourth type of a distress is actually the owner distress. So the owner has some type of a problem, probably with some other properties, but the owner has, like, you know, owns very good structurally and tenant-wise properties that the owner probably wants to sell in order to make their financial situation better. And this is an opportunity. So if we can detect different types of distresses based on the knowledge graph, we actually can make predictions what is going to happen with the real estate and which type of transactions will happen. So we can use, say, label propagation in the knowledge graph. We can say, we know that this is a property that is currently in distress, or this is an owner that is currently in distress. How this distress is being propagated throughout the knowledge graph is something that needs to be estimated. When it stops, how it is being re-weighted over the a semantic neighborhood in the knowledge graph. This is an interesting question to answer, and we don't have a good answer to that. So if you don't mind, since I started 5 minutes later, I'll spend another 5 minutes to discuss the maintenance of the knowledge graph. So we used a lot of data normalization to build a knowledge graph, but obviously we cannot do it perfectly. Still, in the knowledge graph, you would have entities that are represented by multiple nodes, and we need to merge those nodes together. If those are 3 nodes on the left that they have the same semantic neighborhood, and the nodes have similar names, we need to merge them together into one. And that's the entity resolution in the knowledge graph problem that is very important. The trouble is that if we're talking about similar names of nodes and similar semantic neighborhoods of those nodes, we kind of are talking about a quadratic algorithm, right? So run over all the nodes and run for each node, run over all the nodes again to find those similar nodes, right? A quadratic algorithm in a knowledge graph of 500 million nodes is not going to work. So you need to come up with a different way, which is to start with a neighbor. So if you started with a node and looked for every other node that might be similar, that's not going to work. But if you start with a neighbor that has X and Z's in their semantic neighborhood, then what you need to do is to run over pairs of X and Z's with X and Y, within the same semantic neighborhood of Z. That creates the algorithm that is feasible computationally, and you can find pairs of nodes X and Z that should be merged together because they are actually the same entity. And entity disambiguation is a complement of entity resolution. So in entity resolution, you're saying there are multiple nodes in the graph that refer to the same entity. In entity disambiguation, that's the opposite. You have one node in the graph that mistakenly represents multiple entities just because this node has the same name. Here's an example. Jose Gomez is a very common name. And if you have one node in the knowledge graph for Jose Gomez, it's connecting parts of the network that are completely unrelated to each other. And this is a mistake. And if you need to traverse the graph, those mistakes might lead to really wrong decisions. So what we need to do is we need to split this node to multiple nodes. We need to say this is Jose Gomez 1, Jose Gomez 2, Jose Gomez 3, and then the graph is going to be correct. How do we do that? We take the semantic neighborhood of that node, Jose Gomez in our case, and we delete this node and we apply the connected component algorithm. And that essentially will split the semantic neighborhoods to multiple chunks, and each chunk will represent a specific instance of the same name that we mistakenly put as one node. And that's how we split them. So to conclude, I gave an introduction to the commercial side of the real estate. There are many data science challenges. There are very few data scientists who work in commercial real estate. And it's a very fascinating topic. And since it's currently changing upside down because of COVID, this is the best opportunity for us to jump in and to work in commercial real estate and to help the industry survive and get substantially better in the future. And that concludes my part of the tutorial. Saying Cherre is hiring, I think, is kind of obvious. If you guys are interested in joining Cherre, please contact me.